Development of regular solids. In our previous video, we had gone through the development and different methods of development of a solid. Now in this video, we are gonna apply these methods for obtaining development of various regular solids. So basically, we'll be developing surfaces of prism, pyramid, cone, and cylinder. The development of these solids is true development. The development of these solids can be drawn using a parallel line, radial line, and triangulation method. So firstly, we will see how to develop a regular cube or a square prism. As we know that a square prism is composed of plane surfaces and straight edges, it can be developed by using a parallel line development method. Development of a square prism can be done by stretching a line that is parallel to the right section of the prism and perpendicular to the lateral section of the prism. Let us develop a square prism of base edge 40 mm and length of the axis as 60 mm. Step 1. Firstly, draw the top and front view of the square prism. The top view of the square prism is square. So draw a square ABCD of base edge 40 mm below XY such that edge AB and edge CD are perpendicular to XY. Name ABCD as top face and EFGH as bottom face of the square prism. Here the top view of square prism gets completed. Now draw the front view. The front view of the square prism is rectangle. So draw a rectangle having its base on XY of axis length 60 mm. Width of the rectangle can be obtained from the top view by extending the construction lines. Shift the point A', B', C', D' and E', F', G', H' on the front view. Here the step 1 is complete. Now it's time for step 2, that is development. To start the development, draw the stretched out lines in the front view along the base of prism and equal in length to the perimeter of the prism. Since its perimeter, the length of the line should be 4 times that of the base edge, as prism is composed of 4 lateral surfaces. What this basically means is to draw a line measuring 160 mm, say AA, in the front view, along with a bottom face that is square EFGH of edge 40 mm. Now draw another line in the front view along with the top of the prism. For that, draw a line measuring 160 mm, say EE, in the front view with a top face that is square ABCD of edge 40 mm. Distance between these stretched lines should be equal to the length of the axis, that is 60 mm. Mark points B, C, D on line AA at a distance of 40 mm each. Also, mark points F, G, H on line EE at a distance 40 mm each. Now square ABCD and EFGH is the development of top and bottom faces of the prism, and AAEE is the development of lateral surfaces of the prism. Join AE, BF, CG, DH, AE. These lines are folding lines and it can be drawn as dotted, light, or in any way you want. From these folding lines of development, we can fold it and regain its original shape. Like if we fold this development, we can get square prism back. So this is the method to develop square prisms. We had used only parallel lines for development, and so it is called parallel line development. Similarly, other prisms can be developed using this method. Cylinders are also developed in the same way as a prism. The basic difference between the square prism and cylinder development is that the base of the cylinder development is drawn as a circle of the given radius and no folding lines are drawn on lateral surface development because the cylinder has curved lateral surface. But the process of obtaining development of the cylinder is the parallel line method, which is also the same as prism. As we have seen the method of developing a prism, in the same way we can develop a cylinder. So this is how the parallel line development method is used to develop surfaces of solid composed of straight lines. Now let's see how to develop solids which are composed of apex-like cones. For the development of these types of solid, the radial method is used. So we are going to develop a pyramid using a radial line method. We are developing a square pyramid of base edge 30 mm and axis 50 mm. Step 1. Firstly, draw the top and front view of the square pyramid. The top view of square pyramid is square. So draw a square ABCD of base edge 30 mm below XY such that edge AB and CD is perpendicular to XY. Name ABCD as a top face of square pyramid and mark point O as an apex in the center of square ABCD. Here the top view of the square pyramid gets completed. Now draw the front view. The front view of the square pyramid is a triangle, having its base on XY of axis length 50 mm. Width of the triangle can be obtained from top view by extending the construction lines. Shift the point A', B', C', D' and O' on the front view. Here, step 1 gets completed. Now it's time for step 2, that is development. To start the development, shift point O' anywhere on the right side of the development. Now measure the length O'A' from the front view and draw OA on development. Taking O as center and OA as radius, draw quarter circle or semicircle. This quarter or semicircle is called the radial line. Now put 4 arcs on that quarter or semicircle measuring base length, that is 30 mm. Name the points obtained by cutting an arc as B, C, D and A. Join AB, BC, CA and DA by using a straight line. Also join OA, OB, OC, OD and OE. Shift the top view below DA as a square ABCD of edge 30 mm. OB, OC, OD and DA lines are folding lines and can be drawn as dotted, light or in any way you want. From these folding lines of development, we can fold it and regain its original shape. So this is the method to develop a square pyramid. We have used radius for development and so it is called radial line development. In the same way, a cone can also be developed. The difference between developing a pyramid and developing a cone is that cones have a curved lateral surface and base as a circle. So basically, we don't have a base edge that can easily be shifted on a radial line. So for that, we can divide the base circle into 4, 6 or 12 equal parts and then we can shift its base onto the development by putting an arc measuring these parts. So cone can be similarly developed as a pyramid. In this video, we have developed solids by parallel line and radial line methods.